Hi everyone. In my previous video, I presented functional decomposition using domain-driven design. That is how to break a business problem or a problem space into domain and subdomains and then create boundaries that thereby creating multiple bounded contexts. In this video, I will go deeper into the bounded context. So a bounded context is big enough to contain one or more subdomains, and it is big enough to fully express its complete ubiquitous language. Technically, a bounded context can be deployed into one or more modules. For example, if deploying in Java, then it can be one or more jar files. One bounded context is in general one team, one repository, one responsibility, and one ubiquitous language. It should be big enough to encapsulate the complete business language, which is around that domain or subdomain. For example, if we define customer onboarding as a bounded context, then it should include all the concepts related to customer onboarding, such as document verification, address proof, etc. The implementation can be more than one module, but it can be just one package also. We look into the communication and the functional cohesion within classes when selecting those highly related entities that should be part of one package. Theoretically, we can aim for one subdomain getting mapped to one bounded context and one bounded context getting mapped to one module or package. Inside a bounded context, we have services, we have domain logic, and we have the domain model. Um, Those loosely coupled parts of the domain model can be packaged separately, but put highly related parts in one package. The architectural style has been presented as a hexagon or onion, as shown in this diagram. That okay, this hexagon shows this complete boundary, and inside that we have a onion-like structure that is multiple layers. The outermost layer is the application services, which are consumed by the other modules. And then inside are the domain services. Domain services have domain specific logic. And innermost are the domain or data model. So what is a domain model? The model is an understanding of the domain that can be translated into code. Object-oriented programming languages such as Java and .NET make it possible to create the model objects, create relationships among those objects. Thereby, we can translate the entire domain model, which is drawn on paper, into the code in one of those OOPS languages. One of the first things we are taught about modeling is to read the business specification and look for nouns and verbs. The nouns can be converted into classes, abstract nouns becomes abstract classes, and the verbs becomes the methods. Remember, not all the classes are the same. Some of them are entities, and entities are a category of objects that have an identity, which an identity remains same throughout the state of the software. For example, we define a customer and customer ID in the class, and when we instantiate that class in a customer object, it will have some unique ID and it will remain same. Entities have related value objects, and value objects are used to describe certain aspects of the domain, and it does not have an identity. It is thin, it is simple, and it is created and it can be discarded. It is immutable, and it is created with a constructor, and it's generally never modified during the lifetime. When requirement, then a different value for a different value, then you can create a new one. Typically, data transfer objects are used. Data transfer objects are the value objects. An aggregate inside domain model, there are also aggregates, and aggregates are the group of the entity and value objects. Aggregate is a group of associated objects which are considered as one unit with regards to data changes. An aggregate is demarcated by a boundary which separates the object from inside from the outside. Each aggregate has one root. This root is a root entity. For example, customer aggregate will have a customer entity, and then there can be some related value objects such as customer address is one value object. and there can be customer contact, etc. So customer address is a value object. It might include customer ID, but that customer ID is not uniquely for identifying this object. Instead, it's a foreign key like relationship inside the customer address value object. Um, Inside a bounded context are also services. Services provide a functionality for the domain, such as create a new customer, delete an existing customer, create a new account, etc. Services are stateless. It can group related functionalities involving multiple entities and value objects, such as creating a new customer might involve a sequence of steps. And if a service is strictly about the domain object, it is related to one domain and it belongs to the domain layer and called domain service. It may cut across multiple aggregates within that package or within that bounded context, but it conceptually belongs to the domain layer. Whereas we can also have services which will cut across multiple domains and they will conceptually belong to the application layer. But always use stateless services inside the domain model to perform the business operations that don't naturally fit as an operation to be written inside the entity or the value object. Let's move. And application services reside in the application layer. These are different from domain services. They don't have domain logic. Instead, they just are like, sometimes they are just passed through layers. They may control persistent transactions and they may include security. They may also be in charge of sending and receiving events-based notification to other systems. So if this bounded context, when it's deployed like a microservice and it receives some events, then those events will be received by the application service. Those events can be some kind of command. Those events can also be query. Application services remain lightweight. They perform the coordinating operations among the domain objects. If the application service seems to be becoming complex, then it's an indication that the domain logic has leaked from the domain layer to the application service layer. In many real-life examples, you might have seen this controller class, which is an application service, and what it does is mostly is just takes the request and passes on to the service class, and that service class is the domain service, and controller is the application service. If we relate this to the layers of API, experience, system, and process API, then we can say domain services map to system APIs and application services map to the process APIs. Inside a bounded context or inside a package, there are also factories and repositories. Factories are used to encapsulate the knowledge necessary for object creation, and especially useful to create aggregates. When a root of aggregate is created, all the objects contained in the aggregate are created along with it, and all the invariants are enforced. This is important for the creation process to be atomic. There are times when factory is not needed, and maybe a simple constructor is enough. A repository, the purpose of which to encapsulate all the logic needed to obtain an object reference. The domain objects don't have to deal with the infrastructure to get the needed references of other objects of the domain. They will just get them from the repository. And the model is, so repository may store reference to some of other objects. When an object is created, it may be saved in the repository and retrieved from there for later use. If client requests some object from the repository and repository doesn't have it, then repository will go to the database, fetch the object, and return it. So repository may include cache, may include a database. From the rest of the classes perspective within all this package, repository represents database, repository represents the cache. This is how a package structure might look like. So there is an application layer, there is a domain layer, and application service belongs to one domain, or it may cut across multiple domains. Domain services may cut across more than one aggregate. Application layer has DTOs, and application layer receives the events from the external external packages, modules, microservices, bounded contexts. And those events can be commands, they can be queries, or they can be just events. Whereas application may have a service class that might have some coordinating logic across multiple services which are in the domain layer. Whereas it might be possible that there is no need for such an application service, then domain service is enough. And outside this application layer are the REST APIs. There can be all type of user interfaces, command line, including command line interface, including some configurations, installation, including some infrastructure. So even including layer for how to receive the events from infrastructure perspective, even REST APIs. Controller class can be outside, but it's not necessary. It's just a recommendations. At some places, we might see that there is a controller class, and some people might call it that, okay, this belongs to an application layer, and it's true. So, but ideally, if you have a little bit complex or complicated bounded context, then you can follow this structure. You can write a controller class that will be an API, which is invoked directly from the external world, and then you can have an application package, and inside application package, we can have service DTOs, events, queries, which are directly communicated from inside and outside. And then inside you keep the domain, which is totally hidden from the outside world. So this domain includes services, but they are not directly invoked, entities, aggregates, etc. But they are not directly invoked from outside worlds. In this package structure, I have kept separate DTO and value objects. So I've created value objects inside the domain layer. I don't pass this value objects directly to any external client. Instead, they are translated to DTO, and then DTO gets passed on. Whereas if the microservice is a very simple, small one, then we can skip a lot of classes here, or a lot of package structure here. This is one more example of a package structure wherein I have a controller.java, which is a interface to the external world. And I have DTOs and events inside the application layer. So I have skipped the service layer inside the application package. And because there was no need, and I took this example from Microsoft documents. And then inside the domain, I have services entities. So my controller class directly invokes the service class of the domain layer. There were no multiple domains. There was no requirement to perform any kind of coordination or orchestration among multiple domain services. So my controller directly invokes the service of the domain layer. I also have actually exception and util as separate packages. Another example of a modular monolith in which I have put multiple domains inside one package. So in fact, this is structure I followed while working for an MVP. And at that point, I didn't know that, okay, how many domains or how big this application is going to be in future. That's why I put all those domains I identified during the functional decomposition. I put them inside one monolith package. I knew that, okay, in future more requirements will come, and the problem is space in itself doesn't have a boundary yet. So I created domains based on the business problem that was given to me as a requirement for the part of MVP. I knew it will grow a lot, and more domains will be recognized in future. I put all the domains inside one package, and I kept domain one separate from domain two. So everything that belongs to domain one, service, aggregate, entities, repositories, events, everything was inside the domain one package. And then there was a domain two package that included everything belonging to domain two. So I didn't put all the services inside one service package, and I didn't went for a structure like abc.service.domain1. I knew that will create a problem in future in terms of when I will need to decouple things. So I created abc.domain1.service, abc.domain1.aggregate, etc. And in similar abc.domain 2, domain 3, etc. Wherever required for coordination or orchestration among different domains, I put it in the application there. Later, when it was needed to when a particular domain got bigger and I need to take that domain out of this package, it was easy for me to do this. Thank you. Now, since now this was the fourth video in the series of the solution architecture, and we started with a business problem. We created we created bounded context from this problem, and as these bounded contexts will be our smaller solutions. And then we looked what's inside the bounded context. In my next video, I will look into, or I will explain how these independent modules or components can communicate either asynchronously or synchronously. Thank you. If you like the video, please like the video. If you like to be updated about my upcoming videos, then please subscribe. Thank you very much.